So for this problem, we have to find what the mass of the block on the left is, so that little m. So first what we're going to go ahead and do is we know that the change in the time is 0.53 seconds. And then we want to find the change in y because the acceleration is 2 times the 2 times the displacement of y over the displacement of t squared. So to find the displacement of y, it's going to be 1/2 times the displacement of t squared. And we go ahead and plug in these numbers, but we first want to find out this acceleration. So using the values that we already have, we can go ahead and find that. So we have that 2 is we have that 2 is that constant, and 1 is a change in y, since it literally tells right there that it's 1 millimeter over 0.53 squared. So we have 2 over 0.28, which gives us 7.14. But for this problem, we're just going to go ahead and round that all the way up, and we're going to make it 8. So to find the tension, we do mass times the gravity minus the tension equals mass times the acceleration, which is, in this case, the mass is 100 times gravity, which is 10, minus t equals, again, that mass 100 times 8, which is our acceleration, so t equals 200. So that's the tension going to the right. Now we want to find the tension going to the left. So we go ahead and plug in that number. 200 minus mg equals ma. So 200 minus m times 10 equals m times 8. So 200 equals 18 meters is what we have, or sorry, 18 m, and then we simplify, leaving the m to one side, so we have 200 divided by 18, which is 11.1 kilograms, which gives us our answer.